Okay, so I will start my today's coding practice. So if you watched the video yesterday, I actually solved this question, cracking the safe, but ended up with TLE, I mean time limit the solution. So yesterday I solved this question with backtracking, but today I will solve this question as a kind of graph approach, and I will try to, yeah, um, I mean, implement the solution which is accepted. So I can say this is a continuation of yesterday's video. That being said, let me get started. So firstly, I will quickly wrap up the description of this question. So in this question, I will be given two numbers n and k, and n is the length of the password, and k is the number of possible digit in that password. So, for example, if I'm given n is 2 and k is 2, I will think of the password which consists of two digits because n is 2, and also each digit is either of 0 or 1 because k is 2. And I will think of those possible passwords. I will think of every possible password, and then I will return the sequence of digits which includes all of these passwords as a substring. I will find the shortest such a sequence and then I will return it. Sorry, actually, this isn't. In this case, in this example, 00110 is the shortest valid one. One of the shortest valid one. Okay. So that being said, let me use the board here today. So if n is 2 and k is 2, so I can use 0 or 1. And this means that the password should be two digits. Yeah. So I will think of the graph in this way. So firstly, I will think of every possible password. For this example, I have only four possible passwords. Then I will think if I choose 00, then if I choose 1 as the next number, I can find 01. Yeah, and if I choose 0, I will come back to this password. Then in the same way, if I choose 01, and if I choose 0, I will get 10. And if I choose 01, and then if I choose 1, I can find 11. Then from 10, if I choose 0, I will go to 00. I mean, the next password I can find is 00. And if I find 1, the next password I can find is 01. Then, if I choose 11, if I choose 0, I will find 10. And if I choose 1 again, I will come back to this. So my goal is to visit every puzzle which can be made. So maybe, so I have to visit this and also this, all of them, and I will think of the shortest path which I can pick all of them. So if I start from, say, 1, I can find it in this order. So firstly, I will find 1, then I go to 10, by appending 0. Then I can go find, I can find 0, 0 by appending 0. Then I will append 1, and I will append 0, 1. So in this way, the number of the length of the password is, sorry, the sequence I chose so far is 1, 1, then 0, then 0, 1. Yeah. So probably this is how I can solve this question. And now the question is boiled down into the graph question. Let me take a look at the editorial. Yeah. Okay, sorry. So, but another way of boiling it down into graph question is instead of this, I will choose only one integer. Say, if I choose only one number, it should be 0 and 1 only. Then from 0, the possible password is 0, 1 and 0, 0. So let me think that if I choose 0, I will come back here. And if I choose 1, I go to this. And from here, if I choose 1, I come back here. And if I choose 0, I go this way. So in this graph, each node represents a digit which is n minus 1 digits. Yeah. So, and in this way, I have to visit all of the edges. Yeah. Which means that also I have to visit all the nodes. But I can visit the same node any number of times. Yeah. So let me think of one more example. So if n is 3, then k is, say, 2. This means that I can choose digit 0, 1, or 2, and I have 3-digit password. So each node should have 2 digits. So I think there are 6 combinations, I guess. 0, 1, 1, 0, 0, 2. So let me change it quickly. So oops, I have 0, 1. Also, I have 1, 0, 0, 2, 2, 0, and also I will choose 1, 2, and 2, 1. And the thing is, from 0, 1, if I choose 0, I will get 1, 0, so I can get this. If I choose 1, I will get 1, 1, and the last 2 digits will be 11. Oh, so I forgot 7, 1, 1, and also 2, 2. I can put it anywhere. And also I can get 0, 0. Okay. So if I choose 0, it comes here. I will go quickly. If I choose 1, it goes here. If I choose 2, it goes here. And I have to do the same for each node. Yeah, let me do it. If I choose 1, I will come back here, but I actually don't need it because I've already seen 11 and I don't have to come back here. And if I choose 0, I will get 1, 0. If I choose 2, I will get 1, 2, which is here. Where should I go next? From 1, 0, if I choose 0, it should be 0, 0, so this should be like this. And if I choose 1, this should be 0, 1. Sorry, this is too many. So let me, reduce this example. So instead of that, let me think with this example. So in this example, I have 3 digits, so I will think of 2, every possible digit. And then what I will do is, if I choose 0 from here, I will come back here. And if I choose 1, I will get 0, 1. And if from 0, 1, if I choose 0, I will get this. If I choose 1, I will get this. And from 1, 0, if I choose 0, I will get this. If I choose 1, I will get this. From 1, 1, if I choose 0, I will get 1, 0. No. If I choose 1, I will come back here. So my task is I have to go through every path, in this graph. And I actually don't have to go to this because, oh, wait a minute. Because when I reach here, it means that I get the 0, 0 already, but coming back here means that I can find one more 0, 0 possible. No. If I come back here, it means that I will get 0, 0, 0 password. So let me say this path represents 0, 0, 0 password. And this path represents 0, 0, 1 password. This path represents 1, 0, 0 password. This path represents 0, 1, 1 password. And similarly, how many passwords I have? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So I have to choose, go through all the paths. And the thing is, if I can, at least I have to visit every path. And ideally, I'd like to visit each path only once because it makes the path shortest. And the thing is, it's possible that I can find the Euler path, which I visit every path exactly once. I omit the proof of that, but that's the thing. And actually, I I used that fact yesterday because where is it? So yesterday's implementation. So it was here. So yesterday I didn't choose the same password twice, which is the same thing as what I'm saying now. I don't have to, actually, so, yesterday I thought I don't have to choose or see the same password twice. I was thinking that it's possible to find the cracking, sequence without seeing the same password twice. I actually didn't give a proof yesterday. And the same thing is used here in today's solution. I don't try to prove that I don't have to see the same password twice in the minimum sequence. But seems like that's the case according to the answer. So that being said, I will think of the, solution. So, hmm. So one thing I'm wondering right now is if I can start from anywhere or if I have to choose the correct, I mean, starting point and do the correct path. So I think, for example, if I start from here, I have an idea. So I'm wondering how I can draw the Euler path. Maybe backtracking works? I don't know. Okay, so hmm, let me think that in general, if I do if I have the kind of one path, let me see how it works. So this was the start, this was the goal. So here I can see there is only one inbound and zero outbound. Or maybe if I continue like this, in that case, I will have two inbound and one outbound. But for this has two outbound and one inbound. So I can say this is the beginning and this is the end. But in the case, if I go in a circular way, I can start from anywhere. Okay, so yeah, let me think of another example. So in this case, this is start, this is end. So this has two inbound, two outbound. And for others, I will have one inbound, one outbound. So I can start from anywhere. And if I choose some node, then I have to, okay, let me start with this. Then I choose this path. I can choose any path, but I will choose this path. And then what happens is that this is a, now this has only one inbound, and this has one out inbound only. So here, this has more outbound than the inbound. So I can choose from here. Then I can go in either way, I think. I think how it works. And the problem here is if I choose this, and if I go this way, I cannot come back here. Hmm. So that's a kind of Euler path theory, I'm wondering. But let me think. Hmm. Oh, and I will use the Holzer's algorithm here. So whenever there is an Euler path cycle, we can construct a greedy V. The algorithm goes as follows. Starting from vertex U, we walk through unwalked edge until we get stuck. Because the integers and the just equal, we can only get stuck at U. Okay, so I think this is for the case when okay, so let me go through the definition of Euler cycle. I see. So I'm thinking how this works. So we will record the results of other subcycles first. Let me stop my video and come back. Okay, so now I'm back. I completely understand what, yeah, I mean, not completely, but I roughly understood what I should do after this. So what I'm will be thinking is kind of, you mean, Euler's circuit. So I can say this question is all about the, you mean, so Euler um circuit program. You mean, so on the directed graph. Okay, so let me explain why. The firstly, let me think how many inbounds and outbounds, or I should say in degree and degree, each node has. Yeah, without counting it, I can simply say in each node, the number, I mean, the in degree is equal to out degree in this graph. So this means that this is the Euler circuit. So what I mean by Euler circuit is, yeah, okay, so let me tell you why. I mean, before going forward, let me quickly say why in each node, number in degrees is numbers out degrees. So it is because obviously when I pick the number 00, say 00, I can choose 0 or 1. So, I mean, when I think and when I think reversely, when I think 1, 0, this 1, 0 comes from 1 something plus 0. And this something can be any of 0 or 1, which is any number in the range of 0 to k. And so this is why in degrees is exactly in this case, in this two-digit node case, k, k. And for out degree, I can choose any number, which is in the range 0 to k minus 1. So out degree is also k. So in that sense, in degree, for each node, in degree is exactly equal to the out degree. And so I can say this is Euler circuit, which means that I can find the path which I choose. I can find a path which um, moves each path exactly once, every path exactly once. And also I can say in this Euler circuit, here, this start is equal to end. So let me say this is 0, 0, 0, 0, 0, 0. So if I choose, oh, sorry, it should be 0, 0 and 0, 0. Yeah. And let me think of the case when I choose 0, 1, and then I go to 1, 0, and then I go to 0, 0. Yeah. So in this case, the path I took was from here, 0, 1 to 1, 0 to 0. Oh, sorry, I said I will start from 0. So I will start from 0. Sorry. So I will start from 0, 0, and let me say if I choose 0, 1, then I choose 1, 0, then 0, 0 back. So in this case, the path I took was from here, 0, 0, 0, 1, 1, 0, then 0, 0. I can say it finally came back. Yeah. And in the case, if I choose, say, another way, like 0, 1 to, oh, wait a minute. So when I come back to 0, 0, I still have to come back to 0, 0 again. No, 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 no. Wait a minute. So sorry, when I started from 0, 0. Oh, so okay. Sorry. I decide that I start from 0, 0. Oh, sorry. So I have to find three-digit numbers. So when I start from 0, 0, and if I go to 0, 1, which means that okay, I have to see the path, digit on the path. So this this is exactly the path if I choose 0, 0, 1, 0, 0. So in this way, I choose this and also this. So 0, 0, 1, 0, 1, 0, 1, 0, 0 is chosen. And the thing is, I keep going until I don't choose the same path twice. So because I still haven't visited this path, and it is possible to move that path from here, I will choose that path. coming back. And if I choose that, which means that I also went this path, so 0 is appended, and I can say 000 is also visited. However, there is some passes I haven't visited, so which are, say, this and this and this and this. So I haven't visited this path. So where should I visit this path? It's exactly after I come here. Or maybe I can start it from here. So if I decide that I visit, say, 1, 1 after this, it happens like this. So I go to 1, 1, then 1, 0, and coming back. Yeah. I still haven't visited 1, 1. Oh, sorry, 1, 1, 2, 1, 1. Yeah. So I mean, this path isn't visited yet, so maybe I can say, also I can say I visit this and this. Let me change the color. Also, I have to visit this and this. So, which means that, I mean, simply saying, I mean, summarizingly, summarizingly, I can say I try to visit the path in this way. So I start from here, then here, 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 this way, right? Yeah. And for that, firstly, I mean, intuitively, I find this path first. Then I find that green color path hasn't visited yet, so I find this path. Then I also find that purple color path that hasn't been visited yet, and I find that I can start from here, so I also append this path. The important thing is that firstly, I will go as much as possible. This is number one. Then from some node, I will find another path I could visit. This is number two. Then from the paths, one of the node, I again think of another path I should have visited so that I visit every possible path. So that's the thing. And when I think of this as a graph traversal, I can say I should do the post of the traversal. So, because if I go this, and then if I go this, that's theoretically correct. But if I start from here, then if I go here, 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 okay, so let me say I try to visit these nodes in this order. So 1, 2, 3, 4. Then no, so sorry, I will think of the path. So 1, 2, 3, 4, 5, 6, 7, 8, 9 in this order. And for that, if I choose this and this, this, I mean, a greedy way, I'm happy if I can take this path. However, it is possible that I ended up with this path and I don't know where I should come back. So instead of that, I use the postular traversal. So I start from here. Then, okay, so if I decided to use the postular traversal, what happens is that, okay, let me write it down here. So again, you can think of this as a graph. So if I use the DFS, I mean postular traversal, what happens is that I go this, I go this, I go, maybe I have to go this or this. Okay, let me write it first. So what happens is that I reach here, but still, okay, let me think of this as the postal the DFS on the path. So before visiting here, I have to mark the next path first. And then when I'm here, I pass post this here. Then here, I post this, mark this here. So the order is this one will become first, second, third, then I will see this one. Maybe I go this. And so this one, and this one, this one, in this order. So what I find is that I find the path in a reversed order. So I just have to, I mean, reverse the whole sequence, and then I will get the order I shown before. Actually, I'm not 100% sure, and I haven't got the clear image on this, but this is basically how it works in postular traversal. Okay, so that being said, let me do the implementation quickly. Mhm. So this is the Euler circuit undirected graph algorithm solution. So I start from 0, 0 and all the way to 0, 0. So this is start and also end. Then what I should do is reverse and the current. And also I have to remember being positive. And also I have needs to stack. Sorry. No, I should say reverse path. Or I should say path. I just say path. Okay. So I start from DFS from start until end. Then after that, I will get the path. So what I will get is I start from 0, 0. Then after that, I put all the paths. So what I need to do is I have to append 0, 0 first. And also I have to append 0, 0 in the end. Because all I can store in the selected paths is paths only. Okay. So yeah. Okay, so what this is what I will return. Maybe I can just say this is enough. Okay. Then I will do the postal traversal. So here I can choose. How can I remember the path? So let me say this as yeah. Let me memorize this with the nodes, start node and end node. So that being said, I can choose any number in this way. And next node should be like this. And if this is already seen, I will continue. And otherwise, I will visit it. And so I will traverse it. in this way. Yep. And what I have to take care is if I go this way, I have to mark it as thing immediately. But append to the path list after coming back. So okay, let me remind this to current node. Okay, so in this way I traverse the node, and after coming back from the journey, I will append this. Sorry, after coming back. Oh wait, so what I'd like to get is pass. Yes. So after coming back, I will append it to the path list. Hmm. Okay, I think it works in this way. Yeah. Okay. So let me run my code with this. Oh, sorry. This should be tuple, and also this should be current node. Can only concatenate string, not with the string. Okay, so I see. So for this solution, let me just ignore the small optimization. Let me just aggressively join and add in this way. Int font. Sequence item 0, expected string is the... I see. So for this path, let me append string D so that I can generate. Okay. I think I'm almost there. Somehow node 1 is not visited at all. So why is it? Hmm. Oh, wait. What am I doing here? So, okay, I see. So in this way, hmm. Wait a minute. So, Let me quickly change this. Yeah, so let me think of this n is one, case two, and work away, work around. So if if n is one and if k is two, so in this example, possible digit is 0 or 1, and there is exactly one digit here. That being said, when I build the graph, because n is 1, nodes should be empty, and from this empty node, I have two possible ways, 0 and 1, and in either way, it will come back. Yeah. So what I should do is begin from here and maybe I visit 1 and then 0, or I start from 0 path and then 1 path. In either way, I should get 1, 0. But when I do the traversal, I visit range 0 and 1, and next node should be current node, oh, from 1, should be empty, plus 20, which should be 1 or 0. So next node should be 1. Okay, let me think if I start from 0 and if I visit 1. Oh, if I visit D is 0. In this case, next node would be D, which is 0. Wait, is this correct? No. So what I need to do is let me add this string first, and then I will get, yeah, index from 1. So in this way, the next node should be again empty. So this should be, no, it doesn't work because when I just keep track of the current node and next node, this one path and this path would be the same, which is not true. So let me say like this. Yeah. And for that, I will add D to here and D to here. And let me try it again. Okay, so for this case, it's okay, but for case 2, it didn't work. Hmm. So this is the case when n is 2 is case 2. So let me think. So in this case, digit can be 0, 1, and n should be 2 digit. So I will pick only one digit as one node, and then I will have two nodes. And when I choose 0, I come back here. And when I pick 1, I will come here. When I pick 1, I will come back here. When I pick 0, I will go from 1 to 0. Yep. And I said I will start from 0. So this should be start. And also this should be goal. Yeah. And what I should do is, firstly, I will visit the k is now 2, so I have 0 and 1. So if I pick 0, I will come back here. Sam, let me see. So firstly, because I went from 0 to 0, and also the past digit is 0, so this is put. And then I will put 0 here. Okay. Yeah. Then I visit this. However, this 0 is not yet passed. So let me keep it as 0 should be passed later. Then I go to say this path, so 0, 1, 1 is added. Then I will visit so 1. Then from here, probably I will visit 0 because I visit some nodes from 0 and 1 order in for loop. So I will visit 0 and then 1, 0, 0 is added to the same path. Yeah. Then, but still I have this path here. So I added this 0 and I need to pass this path, which should be 1. Then I come back and add 1, 0. So it should be 0, 0, 1, 1, 0, 0. Oh, but this is actually true. Hmm. 0, 0. So here I have 2, 0, 0. What do you mean? So this signifies 0, 0, but this also signifies 0, 0. What do you mean? Oh, so I find that, okay, I see. So when I start from node, I, the, when I pick this path, the node should be 0, which was node plus path 0. And when I pick this one, this should be previous node plus path. And when I go this is previous node path and previous node path, which means that I don't need 0, 0 anymore in the end. So I can safely remove this. Good. Okay, then so I will submit my code. Hmm. So in this case, this is 3. So 000 is found, but seems like 100 is not found. Hmm. Let me debug it in this way. So if no, the problem is that I 0, 0, then 0, but there's maybe same path is visited twice. Yeah, I think so. Ah, I see. So current node, next node, the hmm. Let me write here. No, 0, 0. Wait a minute. So why 0, 0 is added twice? I mean 0, 0, 0. Oh wait, next node is 0. Is this correct? Next node. Sorry, D is 0. Yes, 0, 0. So what happens is 0 is appended. Ah, I see. So as I said, I have to reverse this path because as I said, when I do this kind of postal traversal, the last path is visited first. So I have to reverse it first and then I will join it. Okay, good. And I submit this code. Good. Now it's accepted. Okay, so that being said, I will finish my today's question. Yeah, so okay, I will quickly wrap up. So this is a cracking the safe question. And yesterday I solved this question with backtracking, which ended up with theory. So today I try to solve this as an accepted approach, which is an optimized way. So for that, I use the approach of Euler's circuit, building the Euler circuit on the directed graph. And I can say this, firstly, I converted the question to this graph question. So I will think of the node which represent any n minus one digit number. Then also I put the path, yeah, as each digit I choose next from that node. And from here, the question is boiled down into finding building the Euler path. So, because in every node, in degree is equal to a degree, so I can start from any node. Then I do the post of the traversal, and with, I mean, the same path never visited twice. Yeah, so I keep track of these same path and path. And the key here is because I do the post of the traversal in line 24, I immediately add the path as seen when I choose it. However, I append that path to the path sequence after coming back from the traversal. Yeah. In that way, I can build the path in a reverse order like this. Then I will reverse that reverse path to get path in order. Then I will add the first 0, 0, which is the starting node for us. Then I will return the concatenated string. Yeah. So this is a quite tough question, and actually this is my first time to build the Euler path by myself. So it was good. Maybe I will keep posting Euler circuit or Euler trail questions in the next few days. So yeah. That being said, see you tomorrow. Bye.